Hey guys, welcome back. Here is video 2. So this video is actually still in section 11.7 and it's about standard deviations, just standard deviations. And your goal, you're going to try to find the mean and the standard deviation of a data set and determine if a data set fits an approximately normal distribution. So we talked about a normal distribution being kind of like a bell curve, something that's very symmetric. And we're going to see if that data will fit that normal distribution. Now, that's not going to be everything on this paper, but when you come into class, we're going to get some more practice. So let's review. A standard deviation is and this is a slightly different vocabulary definition, but it'll work. So the average distance that varies from the mean. That's weird, right? We have average and mean in the same sentence. But really that's just saying we need to figure out what the mean is, and there's going to be some data above it, some data below it. And this is really what it's going to look like. So when you calculate the standard deviation of your data, you'll find that generally 68%, and that's actually on your paper already, we're just kind of highlighting that, 68% of the data, 68% of the data is one standard deviation, I'm going to call it SD, from the mean. So if we have a symmetric curve and this whole thing, so this whole thing in here is 68%, how much half of that? Well, what's 68 divided by 2? Hopefully in your head you're saying 34. So this side is 34 and this side is 34%. Definitely going to need that for class. Okay? Now the second one, we have 95% of all the values. So 95% of the data is 2 standard deviations from the mean. Well, what does that mean? Well, we already know the center one, so right in between here, this is 68 altogether. That means there's a little bit more off to the right, first two standard deviations. So really what that means, I'm taking 95%, subtracting 68%, then divide it by 2, just like we did last time. That means this little piece in the middle here is actually 13.5%. So far we have this little section at 13.5%, this would be 34%, 34%, and again 13.5%. Now we have to talk about the rest of the data. So we did 90%, that means there's at least 5% left, right? So down here, this is only 99.7%. That means even though we are within 3 standard deviations and it's almost 100, there's a little bit more at the ends here that's not within 3 standard deviations of the mean. But 99.7% of the data is 3 standard deviations from the mean. So disregarding these end ones, right here, this little tiny part right from here to here, this is actually 2.35%. And again over here, 2.35%. These curves are extremely important. You're going to have to use them a whole bunch in order to make some really good decisions about data. So let's do one example, and you're going to get to try one on your own. Let's move this down a little bit. Okay, example. The heights of women in the United States, remember on the last paper, we were talking about how height does do a normal distribution. So the heights of women in the U.S. are normally distributed, important vocabulary there, with a mean of 65 inches and a standard deviation of 3 inches. Now, if you have a highlighter, feel free to highlight instead of boxing. It's up to you. Your first task is to draw a sketch of the normal model. So we'll sketch together. Then we're going to show the 3 standard deviations on that sketch. And then we're going to label the percentages down here. So we have, let's see, let's put our line here. And then let's see how ugly this turns out. Oh, not too bad. Okay, so we have a normal curve. We're going to separate this data. Okay, so this middle piece, that's halfway. And that's my mean. So that's the center of my data. Mean, median, that should all be right in here because it's symmetric. So the mean is 65 inches. So right under here, I'm putting 65. This section right here is 1 standard deviation. Same with this section over here, 1 standard deviation. How much is that? Well, that is 68%. If you want to separate it further, you could write this as 34%, and this side is 34% as well. Now we have to do, we need to figure out what these data points are. So 65, it said that they are the standard deviation is 3 inches. So I'm going to take 65, add 3 to it. So in your head, you should be saying, oh, that's 68. So that's within 1 standard deviation. And then 65, subtract 3. You'll get 62. So that's data within 1 standard deviation. Now we need to do our next line. So we have a line right about here. Should be about the same. One right about here. Now this is 2 standard deviations. This whole area in here, this is your 95%. And we have 2 standard deviations. Got to figure out this point. So I'm taking 68, add my standard deviation of 3, so 68 is 3. Hopefully you said 71. Then 62 minus 3. Hopefully you said 59. Finally, we have our 3rd standard deviation. And that information is that 99.7%. Should have done different colors. But this is 3 standard deviations from the mean. Take 71, add 3 to it, you'll get 74. Take 59, subtract 3 from it, you'll get 56. Now, like I said, there is some information here that is not within those 3 standard deviations, and that's the outer edge. So you got to keep in mind it's not 100%. From here to here, though, so from the very center all the way to the end, this is 50% of your data. So right from that center, that symmetric line, half is 50%, the other half is the other 50%. Now we're going to answer some questions. I'm actually going to answer the ones on the right first because that's just how it is. So use your model to determine the percent, so I'm looking for percents here, of women whose height in inches is between 62 and 68. So between 62 and 68, and this is inches. I'm 63.5, and you know how short I am. So 62 to 68, that's my 68%. Between 56 and 74, so 56 to 74, that's my 99%. Between 65 and 68, so 65 and 68, we wrote up top here that that section is half of 68, so 34%. So that's what I am going to put on that line right here. Okay, so we're half done. That was pretty easy. Now we have to look at greater than 65%. And we talked about that already. So from 65 all the way up, so that's greater than 50%. So percent of the women in the United States are greater than 65 inches. Makes me feel short. Now we have two where we actually have to think a little bit. So less than 59%. I'm going to come over here, less than 59 right here. Let me change colors. So from 59 on. But we have to keep in mind there's this green stuff. I don't know exactly what percent is. So I'm going to say from 59 to 56, or less than 59 I should say, all of this data right in here is how much? Well, let's look at it. So from here to here is 2 standard deviations. That's 95%. That means both of these ends, from 59 to 56 and 71 to 74, are 5%. What is half of 5? Because I'm only looking for the left-hand side. I don't want to know both. I just want to know what is less than 59. Well, 5 divided by 2 is 2.5%. Last one. We're almost there. So greater than 62. Well, let's look at 62. I'm going to change colors one more time. So I am looking for all of the numbers that are from 62 onward. So from 62 to past 74. Well, I know that from 65 on through 74, so greater than 65 is my 50%. We answered that in the first part. So I'm going to actually show a little bit of work down here. 50% plus, now we need this little piece right here. Or, sorry, right here, from 62 to 65. So from 65 onward is 50%. What's this piece in here? Well, we answered that question over here. So between 65 and 68, that area is 34%. So that area is 34%. So 50% plus 34% gives you your 80%. Okay, so you have a you try it. You're going to bring this to me to class tomorrow, or whenever you're viewing this, the next time I see you. I need you to do the same exact thing we just did. So you're going to sketch your bell curve, percentages in here as well, so you get used to it. Make sure it's your mean in the middle, and then your standard deviations up. Okay? Bring this to me next class, and we'll go over it.